Let's go through LeetCode 2876, countability nodes in a directed graph. This question gave us a directed graph consists of n nodes. It uses a list of integers to represent the edges. So it says that the n nodes is the same as the list size. We know for every graph, every node, it can have only one out degree. So you start at node I and keep visiting other nodes through the edge until you reach a node you have already visited before on the same process. So that means if you start at 3, right? So you can visit 0, 1, 2, and this is 0 you visited. So totally you visit 4 nodes from 3. So it is possible there is a circle in this question. And possible there is no circle as well, right? So in this case, if we start as A, this will return 3 for this node, right? So it asks, it return array asks you start from each node how many nodes you visited. So for this question, we know for directed graph, it can form a circle. So there is some kind of features or properties we should know. That is, if these nodes, they are in the same set, it's impossible that for them to form 2 circles for directed graph, right? Otherwise, this node will have two out degree. But it does not mean for this question there is no 2 cycle, because you can have a cycle in one set and another cycle in a different set, right? This is one feature that in the same set, you cannot have multiple circles if it's directed graph, because it has only one other degree. The second feature is that we know for this question, if there is a circle, it's impossible that this circle have out degree. Well, it can only have in degree. Otherwise, for this node, it have multiple other degrees, right? But for this question, we know for directed graph, we can use visited array, right? So we'll have int n equals edges of length. For this question, we can also use DFS topological sorting, right? But in that case, we should first do DFS to find how many sets, and for each set, we use a topological sort to get rid of this kind of leaves. And what I left on the queue is the circle size, and then do DFS to reverse to count how many nodes, right? So that is also doable. But let's do the visited array way. So we'll have visited array equals new int a. So we know 0 means not visited. 1 means visiting. 2 means visited. Okay. And we can use another record distance. We will use this one to calculate the circle size. If it is, we'll talk about the other questions like a critical connection and minimal circle. Those undirected graph. In that questions, we cannot use a weighted array. but we can use a distance array. But for direct graph, we have to use these two. And this will be our result count. Mu int. Okay. So what we are going to do is that for every int I equals 0, I smaller than n, I plus plus. If visited I equals 0, then we do DFS ages. This is our graph I, and visited array, right? Distance array and a count array. That will be our result. And in the end, we just return count. So let's write let's have void, because during the DFS we can compose the result. So list integer, this will be our graph. Ages, int I is our current, and int visited array, int distance array, right? And also int count. And what the first thing we need to do is that we'll have visited I equals 1, right? And then do DFS. Then we'll do visited I equals 2, right? Here, because we want to calculate the weight of how many nodes in the circle, right? So, so we are not exit here, but we'll exit at its child. So it's next or child, right? So in the next will be ages get I. So there are three kind of situations. So if visited next equals 0, this means we didn't visit this, right? Else if visited next equals 1. If it equals 1, that means this is an circle. Else this is visited equals 2. Okay, this is next equals 2, right? So this means we already finished the DFS. So if there is a circle, we already mark that as 2. So if next equals 2, means this kind of current or I, it can only be upstream of the node. So we can just write count I equals count next plus 1, right? Because during that DFS, or when we met the circle, we will update this value. So if this one equals 2, that means we are starting from a node which is outside of the circle, because and also the circle we already visited. Okay. Otherwise, the next will either be 0 or 1, right? So for 0, it is possible that is out of the circle, but it just means this node is not visited. But if this is 0, if we do the DFS, right? So all the root up that, it will mark as 2, right? So that means if next equals 2, that means for this all of the next part, next node, it already finished DFS. So if there is a circle, right? there is a circle, it can only be the downstream of the next. So it will not be before this. So if this is 2, we can set this one as the count as next as 1. Okay. So if we are unweighted, what we do is we'll have distance. Let's do the one next equals 1, right? Because that means we detect a circle. So that means our count I equals what? So we'll say if there is no circle, count next will be count I plus 1, right? But if this one is 1, means we weight this counter next in our previous steps, right? So we'll see the actual steps we weighted. That will be, sorry, I mean distance. Distance next will be distance I plus 1, right? So if it's there is no circle, we should have this equation. But if it's 1, means we already weighted this next in our previous step. So the circle, how many nodes in the circle will be distance I plus 1 minus distance next. Okay. And in the meanwhile, we can if this is 1, right? Okay, so if it is unweighted, what we are do is that distance next equals distance I plus 1, right? Then we do DFS. DFS ages next weighted distance and count, right? So after this DFS, how can we detect say this current this node I is still in a circle? So we'll say if in circle, right? If in circle, so we'll say if something, we'll have count I equals count next. If not in circle, else, right? Else, let's have count I equals count next plus 1. So how can we detect whether this is in a circle, right? So we can do this. So if we meter mate weight equals 1, right? So the next one, we know current and the next, they are in the circle. We can set polar distance. Distance I equals distance next, okay? So in this case, let's say, because we update, we do the backtracking, we update this kind of distance I. So we'll say if distance I is smaller than I say distance next is smaller than distance I plus 1, right? That means because after backtracking, we update this kind of distance. That means we are getting a smaller distance for the next step. So that means I and the next, they are both on the circle. In this case, this counts. We are just set as current as the next one. So let's say if because that means if there is no circle, distance next will equals distance I plus 1, right? So that case, if it's not in a circle, we just have a count equal to next count plus 1. So this will be our result. Page size. If this one equals 1, the circle, this will be, so what's which one? 3, 3, 8. After DFS, we will also update the distance. Okay, for the one which in the circle, we'll also have distance I equal distance next. Otherwise, so this means they are in circle, right? In a circle, we'll use the distance array to detect whether I and next, whether they are still in the circle, right? So that means if we update this, then this I, so when we backtrack to its parents, we can compare its parents and I, right, to see whether parents are still in circle or not. So this two is used to make sure I still in circle. Okay. So these two statements. Okay, so this is the DFS way to write this question.